Please, Christian.
Thank you, Martial, for the kind introduction. Thank you also to FIFA for the opportunity to present to hold this presentation here at this place. First, I would like to give you a short overview about my talk. So I will present you some basic principles about EPO and why it is so difficult to detect, and then what detection strategies we have currently in the labs established, and the focus will be on the immunological methods, because these are the ones which are currently the most sensitive ones for EPO in particular, not necessarily for instance, hematite, which is some sort of synthetic peptide, which is also acting in this category. And then I will present some recent developments. So regarding EPO and prohibition of detection of erythropoiesis stimulating agents, which is EPO one of them. So they are being described in the prohibited list of WADA, chapter 2, subchapter 1. And based on this, there's a subgroup developing the technical document on this. So this document in the recent version is 2013. I will talk about this in a few minutes. And this is more or less the testing strategy behind it, and which method should be used and in which combination for the screening and the confirmation procedures. So regarding EPO, why is it so difficult to detect? First of all, this is a glycoprotein, and the glycoprotein is unfortunately the recombinant and the endogenous is very similar. So the only thing we can use for differentiation is the sugar content. So there's a huge amount of sugars on the protein itself, and this makes it possible to differentiate it for a certain period of time. So this explains why it is called erythropoiesis stimulating agents. All of these reagents, because it's not only a recombinant EPO, there are several derivatives of this one which also stimulate erythropoiesis, and that's why this word has been created for all these reagents which stimulate the production of red blood cells. Okay, and what it makes it next difficult is this extremely low amount. So we have only a few femtomoles, and for those who want to detect this with mass spectrometry, you will immediately realize that it is more or less impossible to use this method. So due to this low amount, it makes things very complicated. And what made things even more complicated is that when EPO detection started about 13 years ago, with the isoelectric focusing method, there were only less than a handful of EPO pharmaceuticals on the market, but since the expiration of the patent for EPO, there are around 100 biosimilar EPOs on the market, which are slightly different compared to the original substances. So, and why this improvement or development of these pharmaceuticals? The first pharmaceuticals had only a very short half-time in serum and in plasma, depending on which route of administration was used. And this has been increased over the years by modifying the EPO molecule, and this is one which has a change in amino acids, and that's why the sugar content gets even higher, and it then stays longer in the blood circulation. And this Micera, which came out in 2007, has the longest half-life so far because it's chemically modified. So it is a polyethylene glycol group, and that's why it is very easy to detect compared to the other ones. So, and one of the secrets of the detection method is that EPO can divide it into isoforms, and these isoforms are mainly produced by some sugars on the EPO called sialic acids, and usually EPO has 14 of these sialic acids. And if you add extra sialic acids, for instance, for this newer compound, which has 2 more of these glycan structures, then it's getting even more acidic. And the endogenous EPO, I will show soon, is somewhat in between these isoforms. And the main reason was that these isoforms have different activity. So the one which is positioned here has the highest activity in human body, and that's why it is so much important that pharmaceuticals contain a specific selection of these isoforms. And the reason for that is that the receptor binding is being decreased, the higher this amount of highly acidic isoforms is. Okay, so the detection methods, as pointed out, we are focusing nowadays more or less on immunological methods for the traditional epoetines and some ELISA methods for the chemical modified substances like sera or the hematite, which is not directly related to EPO. But anyway, for a global screening procedure, these immunological methods based on electrophoresis are the ones which are the most versatile ones. And for mass spectrometry, unfortunately, due to the low concentration and to the non-existing difference between the endogenous compound or the only very small differences, we can only now use this method for specific compounds. For instance, this NESP, which has been modified chemically in the amino acid sequence, and the hematite, which is totally synthetic. And of course, the indirect methods, which have been mentioned previously, based on the biological passport, by measuring some parameters like these, and then monitoring these in longitudinal style, and then, of course, based on the information from the biological passport, direct testing methods can be then more efficiently applied. So to start with the gel electrophoretic methods, there are in basic, we have three methods. The old traditional method is the isoelectric focusing method, which has been used since 2000. And due to the fact that the EPOs on the market changed during the past couple of years, the positivity criteria had to be also been adapted. And that's why in 2008, the STS page method, which is a more or less completely different method compared to that one. This one is focusing on the charges on the molecule, and this one is focusing on the molecular mass of the molecule. And this has been used specifically for the detection of dyne-EPO. This is a compound which is being produced in a human cell line. It's no longer in the market, but our laboratory was the first to report cases in that one in 2008. This is a bit confusing. I mean, the pharmaceutical was approved in 2002, but came on the market in 2008. So with this method, we could detect it very easily, and I will show some case studies with this one. And of course, the technical document was then modified in order to have this data, these new methods implemented. And the latest method on the electrophoretic side is this sarcosyl page. This was more or less a modification of the STS page and was specifically developed in order to improve the sensitivity for the MySera. I will show some data about this. And it's now in the technical document, also 2013. So regarding the isoelectric focusing method, as mentioned, we have these isoforms, and the endogenous isoforms are mainly in this region. So if you apply this recombinant EPO, then you shift this profile upwards to this region, and that's why it can be detected, or downwards to this region. And this is, for instance, the sera, which has an isoform profile like this. It's also in this basic region of the gel. So now, what about the biosimilars? I mentioned that since the expiration of the patent of the regular recombinant EPO, about 100 biosimilars or even more on the market. And as you can see, they look, these are the traditional EPOs, and here the urina EPO look quite different compared to the original compounds. So, and that's why it had to be used to modify the document in order to also capture these compounds. So why the STS page method? As mentioned before, it is a method based on the molecular mass for detecting EPO. And what happens is when you apply it, usually you shift, you can see here the recombinant EPO and here the endogenous one, and the endogenous one has the advantage that the molecular mass is lower than the one of the recombinant EPOs. And if you apply it, then you also increase the molecular mass of the endogenous compound. So this is the principle of the testing procedure. And as you can see with the biosimilars, it's getting also a bit more problematic because you get some EPOs which also have part of this molecular mass in the endogenous region. So to give you a short overview about how these two methods work together, first of all, we have the isoelectric focusing method, which generates an isoform profile, which is only based on charges. Then we have the STS page or sarcosyl page, which leaves you a molecular mass profile. And in this case, it's the glycoform. So it's not only charges, but also structural differences, which generate a different molecular mass. So this is how it looks. And if you combine both together, you can see that all of these isoforms have a molecular mass distribution. That's why this molecular mass distribution generates a band which looks like this. So if you use one of these only methods, then you get part of the picture. The entire picture looks like this. This method is, of course, very time-consuming, so it's no real option as a screening method. And that's why we talk in this case as an isoform mass profile, because you have some isoforms and you get also the mass information on these isoforms. So, and if you compare now both methods, as I mentioned, this STS page was the first method we used for detecting dyne EPO, but then afterwards the MICERA came, and the disadvantage of this STS page method was that the MICERA, which is shown here, is producing only a very broad band, so this decreases the sensitivity in the detection. But if you modify it, as we did in our laboratory by replacing these detergents, sodium dodecyl sulfate, against sarcosyl, then you can specifically improve the sensitivity for this MICERA compound. The other compounds stay completely unchanged, and their sensitivity is also unchanged. So we could achieve a high increase in the detection of this compound. So if you see, this is the detection when you use normal STS page, and this is the increase in sensitivity when you use the sarcosyl page, specifically for the MICERA detection. So, and if we now compare a couple of these biosimilars, I've shown it before briefly, but you can see there is this combination of isoforms or glycoforms which have part in common of the endogenous EPO and partly in common with the recombinant EPO. So how does it look when we look at cases? So for instance, a typical positive case looks like this. As you can see, the endogenous isoforms of the urinary EPO are being suppressed, and then you get more or less a specific amount of recombinant isoforms. This, of course, is detectable for around 72 hours only, and then it starts to migrate downwards, and you get more or less also the profile within this time frame of the endogenous EPO. And that's why the detection window is quite short of this method. So, and if we compare it now, yes, if you now compare it for the dyne EPO administration, you can see that the molecular mass is being shifted upwards. And these were the cases which we had in our laboratory, which were detected positive for dyne EPO. So, and these are just some cases for the other EPOs, and here for the recombinant EPO. So, in this case, you can see two types of EPO, the NESP and the endogenous one. And as mentioned, this has been reflected also in the technical document. So, in the technical document, we have now these both methods implemented for the confirmation and for the testing, for the primary initial testing strategy, and we have two sub-sections, one for the urine and one for the other matrix, which is blood. So to come to newer developments, first of all, mass spectrometry. This was developed by the Cologne laboratory for the specific detection of hematite, this completely synthetic method. And this works quite straightforward and also provides the necessary sensitivity and specificity. So another development which might also improve the detection is exoglycosidase digestion. So if you digest the EPO's recombinant endogenous, you can see that by application of a certain amount of enzymes, the urinary EPO cannot be further digested, and you can then improve this separation by using 4 of these enzymes. So this is something which you can see that which significantly improves this detection of the two compounds. And the third method is a dipstick method, which is currently under evaluation. So this is, as a screening method, would be nice, but it has some basic things which have to be solved so far. And this was also tested in our laboratory, and our goal was, of course, to have some mass spectrometry method implemented, so we checked specifically the acetylation of the sialic acids, and you could see compared to the endogenous EPO, which has only very small amounts of this acetylation in this group. All of the recombinant EPOs, including all the biosimilars, have this acetylation, so this might be a good marker. So, and last but not least, I would like to acknowledge all these people who contributed with biosimilars so that we could do this study. I would also like to thank our ministry for funding, for WADA and FIFA for the opportunity to present my data. Thank you very much for your attention.